Question number 5.229. A plane electromagnetic wave of frequency omega naught falls normally on the surface of mirror approaching with relativistic velocity v. Make use of Doppler formula and find the frequency of reflected wave. Simplify the obtained expression for the case v is very much less than the speed of light. Right. So in this case, there is a light source which is generating light, and there is one mirror. This mirror is approaching towards source with a speed v. Okay. We have to find out the frequency of reflected wave if the frequency emitted by the source is omega naught. Okay. So how this phenomena would take place? First, light or electromagnetic wave will move from source and it reaches to the mirror. After that, it will get reflected and it is received by an observer. Okay. So in first case, when electromagnetic wave is moving from the source towards mirror, in this case, source is stationary, okay, and observer, which is mirror, is moving towards the source, right? So using concept of Doppler, the frequency received by the mirror, let's write it as f1 or omega 1. So frequency received by the mirror would be speed of light plus speed of observer, because observer is moving towards the source, divided by speed of light into frequency emitted by the source. So this is equation number 1. Right? Now after reflection, this mirror will emit a wave or reflect a wave of frequency omega 1. Now it is being received by an observer. Right? So in case 2, it behaves like the source is moving towards the observer, because this mirror, after reflection, this mirror will act as a source. Right? So source is moving towards the observer and observer is stationary. So case 2, which will give us the frequency of reflected ray, that is omega 2, is equals to observer is stationary, so there will take speed of light only, right, divided by source is moving towards the observer, so this is c minus v, speed of source is v, and frequency emitted by the source is omega 1. Okay. We can establish Doppler relation using very basic concept that if source is moving towards observer and observer is moving towards source and speed of light is c, then frequency received by the observer is equals to v plus vo upon v minus vs into frequency emitted by the source. Now we can derive relations for different cases by changing the sign and putting the appropriate value. Like in case 1, source was moving towards the observer, source was at rest, so this term was 0, okay, and observer was moving towards the source, that's why we wrote c plus v over c. In second case, source was moving towards the observer and observer was at rest, so we put 0 here and we got c over v minus c, right? Now see, if we'll use equation 1 and 2, so from there we'll get the frequency of reflected ray, which we wanted to calculate, is equals to c over c minus v into omega 1 from equation number 1, that's c plus v over c into omega naught, right? So from here we'll get c plus v over c minus v into omega naught. Okay. Now we need to simplify this expression using this relation. So we can take out C from numerator and denominator, and we can write this is 1 plus V over C over 1 minus V over C into omega naught. We can further simplify that 1 plus V over C into 1 minus V over C to power minus 1 into omega naught. Okay, now we can perform binomial expansion of this term using the concept that 1 plus x to power n is equals to 1 plus nx, and we ignore the higher order term if x is very much smaller than 1. Right. So here if we'll take v upon c as x, then it is also very much less than 1 by the given condition. So we can apply this concept and we can write this is 1 plus v upon c into 1 plus v upon c into omega naught. Okay. So the frequency received after reflection is equals to 1 plus v upon c whole square into omega naught c.